So hi everyone, welcome to the session. Today we will talk about DevOps. So you must have seen or you must have heard about DevOps in many discussions. When you may be searching for the jobs, when you go on the portals, you may have seen so many things related with the DevOps. So first thing is, what is DevOps? Why this is a buzzword? Why it is very important in today's world? These all things first we need to discuss. Second thing which we need to understand is this IT industry is not new. Okay, it was there maybe since 1960. People were working there on COBOL, Fortran, then internet came in market, okay, then websites and all other things. So it is not that this IT industry is new, okay, and it was always there since at least since 1960. So what actually we are trying to change? What actually we are trying to change, which our seniors were not doing correctly? What was the reason? Or we are just reinventing the wheel? Correct. So these are some of the questions first we need to understand before even moving or jumping into the DevOps. So in today's session, we will going to talk about the traditional models, agile revolution, DevOps as a whole, Dev versus Ops gap, and then we'll talk about the DevOps. As you see, some other points are also mentioned in the agenda that we will going to cover in our upcoming session. So let's move to the first thing, and the first thing is waterfall approach. So what is waterfall approach first that we need to understand? Okay, what is waterfall approach? So waterfall, as per the slide, if you see, is a process where the development process of new phase begin only after completing of the previous phase. I have opened for you, and in this, I would like to share a few details with you. Okay, so first thing is what waterfall model say. When I talk about the you know waterfall, then waterfall is something in which it is seem like some mountain is there, and from mountain, if water flow correct from the cliff, it cannot go back. Correct. So same principle we can apply in the waterfall model. For cloth industry, you can say, or you can say any industry, just to make it as a general. So now, pre-pandemic, what he was doing, he was selling a lot of clothes. So sale was booming for him. Okay, and then pandemic came. So as soon as pandemic came, what happened? People stopped going to market. They stopped visiting the shops. So it started impacting this guy. Okay, because during the pandemic, people started, you know, they learned actually gradually how to use the mobile applications. Many folks who were not very much tech savvy, they also learned how to use the mobile application in a proper way. So now, even after the pandemic, they were not going back to the shop, and his sale was not picking again from this point. So now, this guy obviously was facing a lot of issues, a lot of loss was happening, correct? And when a lot of losses were happening for him, what happened is he was not happy, obviously, correct? Loss was there, he was not happy. He felt that, okay, what I'm doing, okay, complete pandemic has spoiled my business. So then what he did is he talked with one of his friend, okay, one of his friend, and he suggested that go to some IT company and they may help you in making some website. Okay, they can help you in making some website. What type of website they can make? They can make some like shopping website where customer can come, they can buy your cloth, okay, they can place the order, and then you can deliver to their address, and that way you can change the way in which business work. He liked the idea, so what he did is he went to one of the IT companies. Now this example what I'm giving you, this is just, I'm just replicating it in terms of one cloth vendor or an industry small shopkeeper, but in actual industry same thing happen. Medium scale industry or large scale enterprises, they do the same thing. Okay, customer come with some requirement, so IT is the core business enabler. If core business will be there, then only IT will be there, otherwise there is IT cannot survive. Okay, so this person will come. Now what this person will do, this person will say that, okay, I actually need one website. Okay, so now from IT company perspective, who all come into the picture? There is something called enterprise architect, then there is something called solution architect, then you can say business architect, sometime functional architect. They all actually talk with this person. They talk with this person and they actually take the requirement. So first phase, whatever I told you earlier, requirement gathering in the slide, these folks do the requirement gathering with this customer. And what type of requirement gathering? See, first you need to understand is that customer, the way in which customers speak is totally different from what engineers understand. Okay, so engineers may understand all the language which is related with the Java, Kubernetes, React, Angular, Python, so many technologies. But this person may not be knowing anything related with technology. He may only be knowing, or he or she may only be knowing only one thing, that okay, my business is in loss. You can help me. If you can help me in surviving that thing, you can help me in making some money. That is what he want. Correct. So when these folks come and give some requirement to us, everyone cannot understand. That is the first thing which you need to understand. Okay. So these folks talk with our enterprise architect, solution architect, business architect, function architect, and these folks actually take some requirement from these customers. So now say for example, if customers say that my requirement is requirement number one, that okay, I want good website. My second requirement is that performance should be good. And my third requirement is that it should able to store the data. Let me explain. Now the problem is if we tell these type of requirement to our engineers, now engineer will not understand anything. They don't understand what is good website. Correct. When we say performance should be good, store data, all these terminologies are generic in nature. So whenever customer speak, only few folks can able to understand that thing, and then they further talk with engineers to decode that those statements. Okay, again I'm giving very small type of example here so that you can understand, but I'm trying to relate it with our real IT industry. So in IT you can relate with this example, and then you can expand it with the big companies also. Now second phase come, and that second phase will be something called system design. Okay, so now when I say that okay, requirement gathering we have completed, then there is something called system design come into the picture. Now what is system design? System design means that articulating all these things in a form of architectural diagram so that our engineers can understand. Okay, so now let's see if we need to draw this thing, how we will able to draw this requirement as a basic example. Okay, as if I have one server, if I have one server here, okay, and in that web server is installed, and then this is my application. Okay, this is my application, for example. Okay, this is my application. So this is my application here. Now that's it. Correct. Good website part is done because we have multiple templates in our offices for multiple industries. We can take anyone and we can take any good website in Java, React, Angular, whatever, based on the need. But now the second point comes, performance should be good. So when performance should be good, what I can do here is I need to, what I can suggest is I say that, okay, create one more server. Okay, I'm saying create one more server here. Same type of server with same application. Correct. Now same application, same thing I'm creating. Now, what next? The next thing is now if I say that okay, now we have the multiple thing here. Now we have, for example, like two server. Then how we will reach to the this server? That is another thing which we need to see. Correct. So what I do here is let me take some users are there. Correct. Now these users, say for example, they want to connect with this application. They cannot directly connect with this now because there are two servers now. Okay. So that means there should be something in between like load balancer. Okay. So load balancer should be there, which can help them in splitting the traffic between this application and this application, so that if I want to define that okay, 50% traffic should go to the first server and 50% traffic should go on the application, this server 2 it can do. Third thing, maybe I will say that okay, because from internet traffic, you know it, that whenever we say that okay, from internet, if you write google.com or anything, what you do first, it go to the DNS. Correct. And then from DNS I will say that okay, now it will connect with this load balancer, and then from load balancer it will connect to this. Correct. So now what you do is it will solve this performance related problem. Now what about storing the data? For storing the data we need database. For storing the database we need database. Okay, so this is tilted, I know, but let's see here. Okay, so what we do is we will connect this database here. Okay, so this is my basic diagram, correct, for this complete requirement. Now if you see here, from customer perspective, he only asked for three things: good website, performance, storage. But behind the scenes, so many things we have created. So we took some liberty in configuring two server because cost was not an issue. Then design wise, we thought that load balancer we should include, then DNS we should include, database should be there to store the things. So everything we did from our side, and this design so that engineers can understand. So this is something we complete, and this happen in this system design phase. After that, what happen is there is something called system implementation phase. Now this system implementation is the real phase when you implement all this infrastructure. Okay, when you implement all these infrastructure. Okay, so all these team, DBA team, applications team, development team, networking team, storage team, okay, Unix team, everyone will work here. Then you will say that, okay, I want to do the application deployment. So you say system deployment here. Okay. And then finally you will say here that, okay, I want to do the testing also, system testing, whether everything is running fine or not. And then if something creating problem, then you say that, okay, I want to do the maintenance. Okay, so this is typical SDLC lifecycle. If you go for new approaches also, then also you need to know all these things SDLC. It is not that with waterfall model, it gone. It is still there. Okay, and you need to learn this thing. Okay, now let's understand in waterfall approach what was happening in this particular SDLC lifecycle. See all the things, whatever I told you, we completed here. Correct? We completed the diagram, we completed this requirement gathering and everything. But the problem was, see here, every phase was dependent on the previous phase in our waterfall approach. That was the problem here. So if once you complete the requirement gathering, then only you can proceed to the system design. Once you complete the system design, then only you can proceed to the system implementation. Once you complete the system implementation, then only you can do the system deployment. Then only you can do the system testing. Okay, and then only after that, once you are done with this, then only you can do the this maintenance one. Okay, otherwise you cannot do. So now let's assume completing one step. Okay, let's say for each step you are taking 2 months. Okay, so let's take it like this, that you are taking 2 months. Okay, everywhere you are taking the 2 months. So 2 months here you are taking, then 2 months here you are taking, and which is very very normal, correct? Because we are not asking for more. 2 months is very less in big enterprises for doing the requirement gathering only when you do the kickoff meeting and all other thing. Okay, so say for example this is the one, then you say this one, and then you say 2 months here also. So how many months in total? How many months? If you see here, 2, 4, 5, 6, 7, 8, 9, 10, correct? Okay, so if every phase is taking 2 months, 2 months here, 2 months here, 2 months here. Okay, so 10 months, I'm saying that, okay, we are taking approximately 10 months in reaching to this place. And after that also, maintenance may also be something, 2 months. So overall, if you see, we may be taking 12 months for completing this project. Now think about the scenario that this customer is facing losses. Okay, he don't have money to survive. And somehow by taking the loan, he come and he thought that, okay, let's come and let's create a website. Okay, let me invest some money in the website so that I can start getting some return and I will repay the loan. Now in that circumstances, can he wait for 1 year? No, he cannot wait for 1 year. If we say that, okay, our first deliverable will be available after 1 year, he may not be interested in that work. He will say, I don't want to work with you. Correct. So that is the practical reality. That is the practical reality here because of the business requirement, because of business dynamics changes. He may not be interested in going with us. So now what we can do here? Now what we can do here? So if you see here in this slide, requirement gathering, system design, system implementation, system deployment, testing, maintenance, everything was taking so much time. So we said, no, this approach is not good. Earlier it was good, but now when everything is so competitive, correct? If you are taking example of any application, for example, Uber is there, Ola is there, Swiggy is there, Zomato is there, everyone is competing with other. Okay, if one feature they need to include, they cannot wait till 1 year or 2 year. Okay, they want immediately that change. They want that, okay, immediately that change should go in the application. Okay, so that's how this waterfall approach failed with time, and then a new methodology came in market, which was the agile methodology. Now, if we talk about the agile methodology actually again was talking about something which is like which focus on the sprint. What is a sprint? Sprint means that iterative way of doing the work rather than breaking everything, rather than doing everything in one go. If 100 item you need to complete, don't do 100 item in one go. Okay, just wait. Okay, wait and complete. You can decide that, okay, I want to complete 10 item in 15 days. As a team can decide that, okay, 15 tasks we want to complete in 15 days or 10 days. And same way they will do throughout the year. And they will start delivering to the customer after 15 days only. Small feature. What is the benefit? Continuous feedback they can get with the customer, whether everything is going in the correct direction or not. In waterfall, another problem was after 1 year when you were delivering the things, customer may reject everything, or 75% thing they may reject, or 50% thing they may reject. Okay, so it is very important for us to take continuous feedback from the customer that we are going in the right direction or not. So here in this approach, every iteration, when we say 15-day iteration is there, we do this development in time box manner. So we say at first iteration we will develop, discover, design. Okay, then again we will do the discovery, again we will do the discovery, and then again we will do the design. And this is a loop process. We can go back anytime and do the modification in our design. That is the main thing here, which was not there in the previous approach. But now again, agile also failed. Now why agile failed actually? That you need to understand. See, agile was very popular in the automobile industry. Okay, agile came in market because of the Toyota Motors. Toyota Motors successfully completed projects using the agile. Okay, and later all the automobile industries actually implemented the same model, and they started getting a lot of productivity improvement. So IT expert thought that, okay, let's implement this agile, as I told you earlier. They implemented this approach here. But the main problem here was that in our if you see in our groups, in our IT companies, who are the main teams? Who are the main two teams? So main two teams, if you see here, is one team, if you see, is the development team. Okay, and another team which was there was the operation team. So I will say that, okay, anyone who is making the logic is a development team. Okay, or tester, I will put these two categories in this development. And operation, I will put everyone else in the operation team. It can be DBA, it can be network administrator, it can be release manager, build manager, everyone will come here. Now the environment, code was working fine. developers sent the code to operation team to implement it in the production environment. They said that, okay, you please go and deploy it on the production environment. Now, what happened is many time it used to fail. Okay, and now when it used to fail, then blame game start. Operation team say that, like, developer, because developer has developed this code, these developers only developed this code, so they are responsible for this thing. If it is failing, that means it is the responsibility of development team. This outage, if it is happening here in the production environment, it is because of the development team. On the other hand, this developers used to say that this code was working fine in our environment, correct? So we have tested thoroughly. You can see our environment. Maybe operation team folks only don't know how to do that work, correct? And they are the problem, and because of that, it is failing. Now, when these two type of folks were doing some work with the agile was also failing because agile is more about teamwork. And here there was a lot of conflict between our teams only in IT, especially in development team and operation team. So agile failed. We were not able to complete tasks in a timely manner. Productivity deteriorated, and like we felt that, our expert felt that, okay, there is no, we cannot implement agile in our IT industry. So they come up with some idea. They said rather than implementing, this thing first, let's first implement one new approach, which is something called DevOps. Let's make something by which we can bridge the gap between these two teams. Okay, so that they can start understanding each other. They found that, okay, they are not understanding each other because developer is not interested in knowing anything related with the infrastructure. Same way, infrastructure folks are not interested in knowing anything related with the development. So these folks say that, okay, it now going forward, we will make it mandatory that if somebody is a developer, they should know at least 5% things related with the infrastructure. Same way, if somebody is from infrastructure or operation team, they should minimum know 5% development. They cannot say that, okay, I don't know development, 0% development I know. Okay, so these days industries need someone who is all rounder. If you are a developer, you should understand infrastructure also. If you are infrastructure guy, operation guy, you should know development also. Why it was helpful? Because now people start understanding each other's problem. They started understanding that, okay, this code was working properly. It seems I have not only set the Java parameter properly on this production environment, because this is the new server. We haven't set the environment variable. It was not there in the document. So I can set Java parameter like this. Same way, developer came to know that, okay, in code, if they say open cursor, it can exhaust a lot of memory and it can break the infrastructure. So they started doing some sensible coding. So that was a very, very good approach, which helped in improving the productivity. That is one part. Okay. Second part, if you see here on the slide deck, it's showing you that automating infrastructure and workflow and continuous performance monitoring. So DevOps also talk about automating the things. Okay, and we will see that thing in our upcoming session, that how we can do the automation. Okay, but as of now, bridging the gap, industry experts did, they said that, okay, just let's bridge the gap between development team and the operation team, and they created this group under one manager, for example. There is no necessity for doing that thing, but in most of the organization now they are doing like that, so that people can be accountable. One manager is handling developers and operation team folks, so that there should not be any blame game. Okay, they make sure that they should be able to solve the problem rather than blaming each other. Okay, so this was the DevOps model. Going forward, we'll see how automation come into the picture, where agile will fit, whether it will come back again or not. Those all things. Okay, so as you see here, like I already spoke about so many benefit here. If you go for the DevOps, you see bridging the gap, increase the productivity. And when I say that, okay, it help you in automating the things, we'll see in our upcoming modules. Then we're going to talk about the continuous integration, continuous delivery, continuous deployment. At that moment, we will explain this thing in detail. But as of now, you can see here the main difference, that in waterfall, if you see design, then just after that coding, then testing and deploy. Whereas in agile, only design, then code test, and deploy finally again at end only. Correct. Whereas in DevOps, if you see the turquoise color is very much prominent at 3 4 places, that means continuously we are doing the deployment means like we are releasing something for our customer. Okay, so that's it for our today's session. I hope you enjoyed this session. If you have any questions or queries, feel free to write in a comment.